And here we go. Okay, everyone, this is week 2, the afternoon session. I've had to push it back to 3:30 because of a all hands on deck meeting for the company. And so I'm gonna keep this nice and concise for y'all. We're gonna just make this real short. All right, I'll try to keep it under 30 minutes, in fact. So timer's on. And so I will show us what today's content will be. It's going to be about join tables. Joining tables. Okay, so here we are. The first thing we're going to need to do is populate some connected tables. And in order to do that, I want us to take a look at the platform here. And I'm going to send us a link of where I'm going to create what I'm going to create. I'm going to create a database that looks just like this. Okay. And since this morning we all participated so well, I won't ask any questions. We won't hold the lecture that way. I'm going to just get this started. All right. So here we are. And I'm going to close everything down. Discard changes. All right, and so I'm going to create a new model. And let's name this here. I'm going to call this, because this is like a Twitter with tweets, I'm just going to call this Dojo, Super Dojo Twitter. Why super? I probably already have one called Dojo Twitter. That's why. Okay. So I'll add this table here. First thing we do is add the table for users. So let's do that. Users. Add the ID. Don't forget to make it auto increment. And now I have my ID set for my table. Here's my table. And I can actually drag it up a little bit more so I can see better. Okay, so let's continue. I have my table and first name. First name. var 255. Last name. Handle. And I don't know that I'll do the whole table. Let me see how long it takes me. Switch this to int. And by the way, everyone, when we create, well, when we start to build full stack apps, we're going to have to create a new database with it, most likely a new schema. Not always, but it's good to get in the practice of doing this, even if it seems monotonous. Do it over and over so you don't forget the process. It's really easy to forget. So handle, I already messed up here. Varchar 255. 255, age is going to be a number. And created at. Updated at. And we'll switch this to date time, as well as this. We learned this morning, we can say current timestamp. And then if we click out, sorry, right click. Ooh, it's not letting me do it. Oh, it's because I'm clicking on the wrong one. All right, so getting a little too fast here. Timestamp and then right click default on current timestamp. So now that we're done with this table, let's go ahead and create a couple more here. Actually, we'll go through the whole thing. So we have our users. Let's create our follows table. So create a new table here. Go in and call it follows. Enter in an ID. Auto increment. And, well, we don't need to create this followed ID. See here, this thing means it's a foreign key. So avoid that pitfall there. And then what we also have here is something called follower ID. So before we create that, I think what I want to do is just say, I think this one we do have to follow. Though I'm confused as to what we would need to create an ID there for. I think it's just the way that the database is created. We're not going to use this so much, I believe. So let's just create it the way it's designed, and then we'll move on anyway. So this one's going to be an int. Sorry for the confusion there. I mean, I looked at this just now and I realized that's not something that is an ID in the sense of these other keys here. All right, so this is just a data that we're giving as you see here. Okay, so created at date time, say now. One more space, okay. Now, current timestamp, and then updated at. Does follower ID need to be auto increment? No, I don't think it does. Well, okay, hold on a second. Let me take a look at this. One, it caught me off guard, and I do want to fix that. So we need to make it date time in order to have that option to select the current timestamp. Okay, be aware of that. So follower ID, what's the point of them giving this follower ID in this follows table? I believe it's there just as a point of data. I don't think it matters if we do or don't. Actually, it does matter because look, as soon as I click here, follower ID right here, see if I click auto increment here, it wants to lose track of auto increment on this ID, which is more important. So this here follower ID, I know it looks like it's two neighbors above, but it's actually different. You can tell by the color of the key. This is the primary key, this is the foreign key, and this one here is just another data point in this table. All right, so we have our two tables, and we want to connect them. So what we need to do is use this one-to-many, because one user is going to have many followers. So we're going to say one-to-many, and we're going to click the follows first, and then users second. That gives us the foreign key on the follows. So now let's go ahead and make that change that we need. We're going to go ahead and go in here and say user ID, and we're going to move it to the top, move up, move up, move up. And we can change it. See, our foreign keys are really named the way that we want them. We are the developer, and we'll set here what our table means. In this case, they don't want the user ID to be the same as users. I will keep it the same as user ID. You can change the name to be followed ID. And that's so that you can possibly read your queries a little easier. But for me, I need to know what this belongs to. So this user ID for me makes sense to connect it to this ID. So this ID is connecting to this one. And so is this one to this one here. So they named it however they wanted. Our default name that we would have been given is users underscore ID. All I did was make it singular. I didn't want to change it to followed ID. Okay, that to me is too much. Okay, so I just want to make you aware of what I'm doing so far. Still creating a database. I have 2 more tables to go, and it will be easier to make this one here. So what we'll want to do then is take this, make this tweets table. So I have 1 more table here. Click here, enter in tweets. Click in here, ID. All right. And so I will see tweet, and then the character is going to be 140 characters. Created at, updated at, sure. Date time. Okay. And then updated at. Nearly done here. All right, updated at. Oh, changed to date time. Sorry. Typical. All right, here we are. And here it is. Now, in order to make this favorites table, do you see how this one is in the center of both? How it has both anchors on both sides, or what I would like call them the join arrow. So grab the many to many and connect your users and your tweets. Okay. Now that you have this middle table here, let's change it to faves. Let's change it to tweet ID and user ID. And we don't need to add the created at or updated at. It just has 2 foreign keys. So it's just a bridge right now. I don't want us to see too much at once and then think what isn't necessary to create is all part of the lesson. So right now I'm just keeping it as minimal as possible. I have a users table. It has a follows table. So many follows to a user. And the relationship between users and tweets are that there's a many-to-many relationship that many users can favorite many tweets, and many tweets can be favorited by many users. So we have this middle table here that represents the favorites, because there's a many-to-many relationship between users and tweets. Many users can like the same tweet, and that same tweet can be liked by many users. All right. So now that we have this, we're all set to go ahead and turn this into a database. We're going to forward engineer it. So let's do that. Click continue, drop schema, continue a couple more times. Put in your password, continue, and successful. All right, so now that we've got these green checks, let's go ahead and go into our database schema. What did I call it? Super Dojo Twitter. Okay, good. All right, here it is. And let's take a look at our users table. Before I do that, I'm going to read the chat and see if anyone has any questions as well. I thought it was one-to-one relationship. Can't one tweet have many likes, not multiple tweets? Wasn't too clear on that. Okay, so let's look at this before we continue. So this here, this middle table here, it represents the many-to-many relationship. And there can be many different types of many-to-many relationships between 2 different tables. So it doesn't matter what we call it. It really just represents a many-to-many relationship between users and tweets. We can think of this as shares or likes or or however the system is designed, right? Like we don't have to have this like clear realization of how Twitter works, how many tweets can have many users, how many users can have any tweets. They can, but in case you're not familiar with the system, just know that this is a many-to-many relationship, and that we want to use this middle table here to gather information about what we would call any connection that we have here that's a many-to-many connection through favorites. Okay, so we're going to see that in just a bit. No, we don't need to put an ID in here. No, we don't need an ID. We certainly can, and we can put a created and updated at. Right now, I'm not going to require it just for this lecture. Okay, so it's not needed, and I don't believe we'll need to know when anything would be. Any test models are not going to require that you show your created and updated at for this middle join table. Okay, more on that later. Let's just learn how we can use this for now. Okay. So we have users and follows. We're going to use this first. We're going to use this first. And in fact, yeah, we're going to do that first. I want to actually go into my schema and make a change. Yeah, I'm going to do that before I continue. So let's take a rewind for a second. And actually, I already have it open. So I'm going to add something in addition to this. I'm going to make a change to my schema and add address as well. Addresses. And here I'm going to have the street 255 city oops, that should be ID and AI. So this is going to be street city state zip. And created at updated at. Okay, so I added one more in here. I just don't think this is helpful enough to show as a good example, okay? What I want to show is that users have addresses in our system as well. But the addresses of each user are not necessarily the addresses of each user. Lost my train of thought. So what I have here is the users table. Oh, okay, sorry. This follows doesn't show enough information as this address here, as this address table. So we're going to connect this using a one-to-many. In our system here, we're going to say a user can have many addresses. It could be one-to-one, it can be many-to-one. It's all up to how we have decided to make our system. I'd say in our system here, one user can have many addresses, okay? So now that we've done that connection, let's go into our table and fix one thing here where we say our user's ID, we make it singular and we move it up. Okay. So here we are. Ooh, I think what I did there was incorrect. Let's try that again. The reason that was incorrect is because I clicked the wrong connection there. I did a non-identifying or identifying relationship. I want a non-identifying relationship option. So let's move that back up. Move up, move up. All right. And as soon as this is finished, we're going to go back to queries. Okay. So now our table is completed. I made one last addition. We're going to forward engineer this again because I had to make an edit there. Let's forward engineer it. Drop schema, sure. Yes, root. Continue. All right. So now that that's done, let's go back to our database. Oh, I set zip code as a date time and data type. Okay. Someone noticed a mistake. Good catch. Where did I go with that one? Here it is. Address. What's you, Brooks? You said I had zip code as date time. Ah, there it is. Okay.
And then I was wondering, I was trying to ask, why is it like they used all dotted line connectors in the diagram and then we use solid ones? I was wondering if that was like intentional.
In the connectors here, we are using dotted lines as well. Oh, I missed that. Okay, so good catch as well. I think I just couldn't see the dotted versus straight. So let's fix that real quick. Let's delete
Can
this.
And
I
then,
interject a little bit?
Oh, yes,
oh,
no, because go ahead. Sorry. Interject, please.
The dotted line means a identifying relationship, whereas a solid line is an identifying relationship, whereas the dotted line is a non-identifying relationship. So if I'm going to write on your screen real quick here, Josh, if we had another table over here that connected to this faves table,
All right. It just crashed on me. So I was
ah,
interrupting your illustration. Yeah, there it is. Okay.
Yep. All right. No worries. Um, if this was a solid line here, then it means that this faves table is identified by not only this ID, but also the user's ID. And so when we create this relationship to this third table over here, we get both the faves table ID and the user's ID because this faves table is identified by the user's table. You will often not have an identifying relationship unless you're dealing with a many-to-many, unless you manually go in and make it a non-identifying relationship. Everything else other than a many-to-many relationship generally is a non-identifying relationship. So it's
that's
easier
what I
to
was wondering.
explain, huh?
Yeah, that's what I was wondering too, because I thought it was with many to manys, and I thought this was all just one-to-one relationships, but you were saying, Josh, that that there was a many to many. That's what I was kind of trying to clarify too, because can't it's just one tweet for all favorites, right? Like favorites can't have multiple tweets.
Well, one tweet can have be favorited by multiple people,
Yeah, so isn't it just like a one to many?
but many users can have one user can have many tweets as well, and many users can have many tweets.
But a tweet couldn't have multiple users though, right? Doesn't it have to be like the other way around to be a
Let
many
me
to
think
many?
about this. So, can a tweet have multiple? So, see, we have to keep it in context of favorites here. So, one tweet can be favorited by multiple users. Fine. All right.
Mhm.
And one user can favorite many tweets as well. Do you see how that works?
Kind of. I think maybe as it plays out, it'll kind of fall into place.
Yeah, you kind of have to be familiar, I guess, a little bit with um think about it in terms of likes, right? So one user can like many posts, and one post can be liked by many users. So there's a many to many relationship there. Mm, and the line between one to many and many to many gets sometimes blurred when we're thinking about how we're going to organize our data. So we have to agree as to which ones are going to be many to many before we start our project. This was actually the hardest part of starting a project for me, writing this part out before coming up with an idea, writing out what is the relationship between my tables. For example, one of my personal projects was a e-commerce project. So figuring out what users would have to have as far as like, orders, what admins could be in relation to users and addresses, so on and so forth. So this is the point of the schema. Right now, we're just given a schema as we see here. And we're just gonna have to believe that this is how this is supposed to be organized, right? I know it's a little confusing. How can tweets have multiple favorites and users favorite multiple tweets? Well, it does work like that. And this is the many-to-many relationship system that we are given right now to try to work with to find out, for example, find all the users that favorited this tweet. So let's not jump ahead because then we or don't have like coherent thoughts here. But let's move slowly. Let's look at what we have here to do. First, now that we've created this table, all right, now that we have it in place, and sorry, SQL crashed, my SQL crashed while Tyler was drawing on it here. So I fixed it while he was finishing his illustration. I've saved it. I'm going to forward engineer it one more time. So let's forward engineer it because I made that last little edit there. And then we'll do our quick presentation now that we've taken a long time to build this. All right, what did we finish? What did we not do? Tweet here. If table not exists, dojo tweet. Oh, did we try to override a table here? Create table if not exists. Super dojo Twitter tweets has users. Oh, okay. Close. And I think it's because we had already created the table and then we made this many-to-many called faves. So if we save it that way, I think we are good to go. Okay, so let's forward engineer this one more time. Okay, fingers crossed. There we go. Okay, so the join table had to be saved as the same way as was before. Okay, moving along. Let's open it up and do some joins. So here we are, our Super Dojo Twitter. Here we go. Let's open up our tables and let's see our users. Okay, so here we have our users table. And as we can see here, our users table doesn't have any foreign keys. Do you see how all the foreign keys are on this one here, and this one? That means in order to fill any of these tables out to make an insert work, we're going to have to first fill this out. We're going to populate this with at least one user in order to allow there to be, for example, follows or addresses. Okay, so step one, we're going to say populate connected tables. And in order to do that, we're going to have to add to our users. So let's select all from users. And let's go ahead and insert into our users table. Insert into users. And then we say what we want to insert: first name, last name, handle, age, values. And then we say here, first name Bob Ross. Okay, and then so we have our value. We're going to insert it into our table. Let's see it again. And here's our first user that we've created. Now that we have completed this step, we are now able to populate our other tables. And looking at this here, who can tell me why again? Why do we need to populate the users table first? Right, it's the parent table. So this one here doesn't have an ID. And so if we were to try and populate this follows table, it's going to say, well, what's the user ID? And if there's no user to have a follow, then there's no ID to fulfill there. Or if we try to submit an address here now, without first filling in a user, it's going to say, okay, well, you can give me a street, address, state, and zip. But if you don't have a user associated with this address, you can't yet fill this out. So when we populate our table or our database in order to start testing queries, we're going to have to use this as our starting point. Use the table that doesn't have foreign keys associated with it. Okay, so let's go into our table here. Well, we already added, didn't we? And I just want to save, just make sure it's not going to disappear on me. Save model. Okay, doesn't want to save, whatever. Okay, so let's then look at our addresses table. This is why I went through the trouble of creating this, because it's a little bit easier to see this data than it is to see follows data, right? So now that we have our address table, we're going to say insert into address the values of the user ID, which is 1, the one ID that we have for the user, and then the street address, which is going to be 1234 Street, city. No, that's not. Yeah, state. Okay, zip code. And I think that's the last bit. Okay. Why doesn't it want the ID? And oh, okay. I made a mistake here. Big mistake. What is it? Yes, insert into, and I want to say what the parameters are here before I say what the values are, right? So let's say values. I got a little excited there. So let's put in here the name here. We're going to say ID. Actually, it's called user ID. The ID is going to be auto generated. User ID, street, city, state, zip, and that should be good. Let's take a look. Let's double check here before we click anything. So insert into address. That's our table that we're currently on. User ID, check. That's what we're grabbing from the one created user that we have. That's there. Street, city, state, zip. Street, city, state, zip. So we're good. Okay, so then let's insert this in. Success. Okay, let's take a look at our view here. And so we have now our address table populated. And as you can see here, I'm kind of doing this a little unorthodox. I'm any table I want to see, I just click this show table button, but it creates a new view here. And so I want to stick to one at this point. All right, I have these statements. I'm going to just copy them over to the one I had previously used for users. I'm just going to paste them in here and start commenting. I'm going to say this is the select select all from users, and this is insert value into users. This is select all from addresses table. And this one here is insert into address table. All right, so now we have our inserts into our tables. We have our users table. All right, it has these values: ID, user ID, street, city, state, zip. Wait, that's not a user, is it? That's an address. I want this one here. So there we are. Oh, I accidentally clicked the wrong arrow, which ran the whole entire thing. So we have a duplicate value. That's okay. So we have two values in our table for, I believe now, users and addresses. So if I see here, these are a list of all my users. And if I say here, click this, shows me a list of all my addresses. Now they're duplicates. I think, just make a slight edit if I want to here. I can say, Lane. This is not the typical way we want to update, but this is like a shortcut around it. I'm going to say Austin and then maybe apply. Okay, so now I've edited some of the values. This is just a quick fix because I wanted to make a point here without doing a edit query or update query. Okay, and if I want to see my values for this here, I'm going to say select all from users. Go back to that for a second. Let's just change some values. Okay, Frank Rosalina. Okay, so now if I click apply, it's saved. So now I've updated my tables. So let's see that for a second. All right, I have my 2 new addresses and 2 new users. Oh, and I didn't actually hit a, well, I didn't change the state. Okay, now this will be my last edit. All right, so now we have 2 tables. We have a users table and an address table. So here we're about to get to the heart of the lesson. What do we do when we want to see, instead of one table at a time, the tables connected? All right, I want to see both the users table information and the address table information. Select all from users and select all from the addresses. And I want to see them joined where the ID is the same as the user ID. All right, so let me flip over here to the platform to show us what I'm talking about exactly. Here's a great example of what I'm referring to. Here we have an example of a users or customers table and another example of an address table. These 2 tables have what in common? This key here, this foreign key should match all of the keys here that say that they are the primary key, the ID for the address. So if these 2 tables match on this column, then what we can do is write what's called a join table to bring them together so that when we select information, we are seeing both at once. Okay, so it's going to be something very similar to this. So in a one-to-many, let's go ahead and mimic this query. All right, so I'm going to say one-to-many join. What this is going to do is bring into one table both tables by this connecting ID. All right, and we have seen how in our schema, users and address, what should they connect on? What's the one thing that they have in common that should be aligned as far as their values? Users have an ID and addresses, well, this table has, the address table has a user ID. So on this particular data point, we can say, I want the information to show from both tables. Yes. Yes, exactly, James. So where users ID equals address dot user underscore ID. So in this place is where we're going to join our tables and make one giant table. And it's going to give us a better sense of our data for a specific query than for asking our database to show absolutely everything and then parsing through it. I have a specific query of my database. I want to ask something very specific related just to users and addresses. I don't need to know about faves and tweets and follows. So I'm going to ask a question to my database. Can you show me the users and their addresses in one answer? Okay, so that's our question to our database. Can you show me that in one single view? Okay, so step 1 is, well, let's see here. We have this keyword join. So we're about to encounter that right now. And let's go ahead and start our select. So this is select 1. Okay, so we're going to say select all. From users. And we can choose to follow this indentation, but I'm going to just write it all in one line to show you that you can join. And what do we want to join to? Addresses, right? Obviously. Okay, answering my own redundant questions here. All right, join addresses on. And then we said here, user's ID equals orders, oh, sorry, addresses dot user underscore ID. Okay, so here we have it. Here's our first join. We're selecting all from users, and we want to join it to our address table on the point, on the column where user ID equals address.user ID. Okay, and so in our example, we're selecting this ID. We're going to join these two tables, users and address, where where ID equals user underscore ID. Okay, so let's run this query. And we got a first error where it says, let's take a look. Oh, I made it bigger, but not more visible. It says, my response at the bottom right says unknown column user.id on clause. Oh, okay. So I made a slight error. Let's bring this back down. User.id. So this one is actually users.id. Okay, slight mistake there, but be careful. As you saw that I can, there we go. Now we have 2 rows returned. All right, so now we have 2 rows. And what do we have here? This is where we have our join. This is what this afternoon lecture is about, the joins. So let's move the interface a little bit around. It will allow us to. Okay, not. There we are. Okay. So in our return here, we have a column or section here where ID equals user ID. And so our first entry was Bob Ross. We had a duplicate, remember? And so we have the same, we have one address, 123 Lane, Austin, Texas. And then our second Bob Ross, he has 123 4th Street in Houston. I thought we had changed his name. I guess that didn't save. So we can go ahead and do that now. But do we see here how the join table brought in data from 2 tables at one? Okay, that's what I want to test to see that we followed along to see. Can we see how a join table brings in data of more than one table? A join query, sorry. All right, so let's see in the poll how well we understood that. I wanted to show data from 2 different tables on their common column. And we were able to see that here through this join statement. I have to admit, when I was a student, this was the hardest part for me to grasp conceptually. So if you're having a bit of a hard time seeing what is going on here and what's the point of this, it's not completely evident as to why we are doing this yet. We're just gathering different data, and we are using now joins to grab data from more than one table. How this will play in fact, we'll see in a couple days how we'll have to use these queries to grab data for the wireframe requirements that we're going to have to fulfill for either assignments or the test. But right now we're grabbing data from two tables at one with one query. Okay, that's all we need to know that we're doing. We're grabbing data from two different tables at once, and that's why we're joining them. Okay, so now we have to know the difference between what a join is and a left join. And it's a very subtle difference. It's very easy to confuse, but it's actually very simple. So let me go ahead and insert another value into users. I'm going to add Vincent, because I just looked at my screen. That's the first face I saw. Vincent, and his last name is G. And I don't know how old he is, but 25 is a good number. Okay, I'm going to run this one here. All right, and I want to see my users now. So I'm going to say, let's see my users. Okay, and we have, oh, I guess we did save that edit. I wonder what our join table didn't reflect accurately. Okay, so we have our 3 users here. We've added a third. And so now I'm going to show us the difference between a join and a left join. Okay, so I'm going to copy the same line and say left join. The difference between these two, let me see that I wrote this right. So I'm going to go to the platform and say left join. Yeah, that's it. Okay. So I'm going to left join now, and let's see the difference if we can tell it. All right. What is the difference that we can tell between this join query and this left join? Can anyone see it? Let me move it a little bit more to the center. All right, what's the difference that we can tell between a join query and a left join? And here's a left join. Ready? Right, we see some null values. Right? We see some null values if we use the left join. And why is that? Why do we see some null values on the left join? Right, so James is saying it lets you get all the entries that have users, right? So we're saying, show me all the users and join the address table where users.id equals address.userid. But don't just show me the users that have addresses. Show me all the users. Don't matter if they have an address or not. I want to see all the users, and I want you to connect the address table to my users table, even if there's no values to connect in the address table to the users table. So a left join will include all the values of the table on the left of the join statement. Is that clear? So this one here, it's going to select all the users and join them on that join table or in that foreign key where users.id equals address.userid. So it's going to connect them. But as far as it's concerned, it's not going to give us users that don't have an address. And we did edit the other user, by the way. We just have two users in here called Bob Ross. So here we only have entered two addresses. Now we can enter in a third address for another one, but we've only entered two addresses at this point. And so any new user entry that doesn't have an address, it's going to be shown when we use this left join, which says join the table on the right to the left, even if there's no values to be joined on. Okay, so I'm going to take a quick poll. How well do we understand the difference between a join and a left join? What a left join will show us as far as data versus a regular join statement. Okay, so we're getting good numbers despite the struggle. And I like that we are following along. So we only have one more thing to show this afternoon. It is, we're going to even skip this. We're going to do more joins, okay? We don't need to even touch this. More joins. On many to many. This is the last point of the day. And it's a little bit heavy, so let's use the last bit of our brain power to focus here. Okay, so let's talk about this join table that I'm about to introduce. So in the instance of our example here, we're going to move away from addresses for a minute. And where did my screenshot go? No, it disappeared. Okay, so we are going to utilize our tweets now. Okay, we're going to put some data in our tweets, and we're going to use this connecting faves table to make some queries. So first, let's populate the tweets. Okay, so we need to insert some tweets. And so let's do that now. Is it that join shows the elements of two tables that have been connected? Yes, and it joins them on the column where they have a common data point. Okay, so let's continue. I'm going to put some tweets in our database. So let's go ahead and put that in. I am here. And so I'm going to write a comment for myself. Insert into tweets. Okay, so I'm going to say insert into tweets. And I'm going to say the tweet. So, and that's it. That's all I need to put. Tweet value. And then I need to put a tweet in here. Let's see. How much would okay. So here we have a tweet. Let's go ahead and insert it in. I'm going to run this now. Oh, we forgot a semicolon. And I want to see if it's successful. Okay, so we have our tweet. We have it inserted. Let's go ahead and view our tweet. Okay. Select all from tweets table. And I think that's all I need. Okay, so here's my one tweet. It has the ID of 1. All right. So now that we have our tweet and our users populated, I want to see one more thing. I want to see our faves table. So I want to see our favorites table. So let's see, select all from faves. Right? What's our faves table? This is the one that's the inner connecting table here between users and tweets. If I wanted to see faves just like this, and I ran this query, something here missing. Tweet ID and user ID is missing any values. So I'm going to give some values to both. Oh, I don't think that's going to work for me there. What's going to happen here? So field user ID doesn't have a default value. Okay. I don't think we need to mess with this for now. Let's ignore what I was just about to show us here. Sorry for that distraction. Let's continue on with our join table. All right. So here now we are going to look at our more complicated join table. What this one is just like our previous one, except for now there's 2 joins, as you can see here. So there's a first one and a second one. And let's run this real quick. Let me see here. I'm going to create one very similar and hold this off for now. So let's put this on pause, and I'm going to say here, multi join table. Okay, so now let's go ahead and follow through with what we see here, and I'll show you once it's finished what it means. Okay, so let's go ahead and select. So I'm going to say select. And from our users table, I'm going to just say first and last name. That's all I want to show for my table. I'm going to say first name and the last name. And I also want to see the tweet as well. And I'm going to select it initially from the users table. Oops, from the users table. I'm going to left join the faves table. All right, I'm going to left join the faves table. So this one here, I'm going to join to users. So I'm left join the faves table here, left join faves. And the place where I'm going to join them is where users.id equals faves at user ID. So where users ID, this ID here, equals, when they're in their case, they changed it to faves, but we're going to say, well, no, actually it's the same. We're going to say where user.id equals faves, our table here, dot user ID. Okay, so let's go ahead and do that. Left join on users.id, where it equals to the table faves and the user underscore ID there. Okay, so we have just joined one table. We've just connected our users and our faves. So we've joined these two now. This second half here that you see, this next left join is going to connect tweets to faves. So once we have this connected to this, now users is seeing which tweets have favorites. So let's go ahead and continue with our query. We're going to say left join. And we said we were going to connect our tweets, right? So we're going to say connect our tweets to our favorites, our faves. So we're connecting tweets to faves. Here we have tweets, and we're joining it to faves that's already joined to users. Okay, so we're adding tweets to faves that's joined to users. Let's go ahead and say on, and then the point that they have in common is faves tweet ID, where tweets ID here. So we're going to say faves tweet ID, this thing here, where this matches this. So this is what we're saying on this line. All right, so let's finish this out. On faves dot tweet ID, where it's equal to tweets.id. And now this last line here is going to specify which user ID we want to see their favorites. So let's see, we have a user ID of 1 for sure. So let's go ahead and see that, where users ID equals 1. Right, so let's go ahead and run this. I want to select all of this here and run this here. Okay. So what do we have? Now we have a join table. We have a left join. And in this query now, we have our first name, our last name, and the last thing we have to fill here is the tweet. Okay, so what are we missing here in order to see Bob Ross's tweet? Looking in the chat. So what if we eliminate this line here? Add a semicolon. We're now being less specific. We're showing all the users, right? But none of them have tweets anyway. Anyone have any ideas of how we can fulfill this here? How we can make them associated with a tweet? My first line. I want to insert into tweets, right? I want to insert into tweets, and I want to also give a value to something. Okay, so if I look into my tweets here, I have an ID for tweet, and I have a created at and updated at. And I've said here, join all my users to my favorites and join my tweets to my favorites where user ID equals 1. Okay, so any more suggestions before I continue? Let's go ahead, do a highlight. Vincent, can we get your help for this one? Are you there? No, he's gone.
What's going on?
Tyler, so I'm asking the class, what do we need to fill in to get a tweet here on our multi-join line? So we have first name, we have last name, and we have a null tweet for Bob Ross, our user ID with 1.
So Bob Ross, does he have any tweets?
Right, so he doesn't. The only tweet we have here is this one tweet that we inserted.
But who does that tweet belong to?
Right, so that is the question. Is this table missing something in order
It
for
is.
us to have?
No.
Yeah,
You need a relationship between tweets and users for the creator of said tweet.
right. Okay, so when we are missing something, we want to go back and do a slight edit. Last change here, we're going to say there's a relationship between tweets and users, right? One user can have many tweets. Oh, okay, just crashed on me. Give me a second. Okay, where were we? Did it not save? Okay. Reopen. No, this is not the one. Okay, I think it crashed before I got a chance to save it. Let me see here. That's unfortunate if it did. What I'll do is I will go ahead and attach like another recording at the end to solve that solution there. Okay, because that's unfortunate. I would have to rebuild that from scratch. I'm not sure why it just crashed on me or where that model went, but let's see if I have something else. No, I don't want to take up too much time. I'm sorry about that, y'all. We're gonna do this. I'm gonna solve this by adding a 30-second recording to the end of the video. Otherwise, the way I would have to have done that is add a join from tweets to user, and that would have been our last bit there. But since I don't want to recreate the whole thing, I am going to just add that to the recording. Okay. So unfortunately, MySQL is giving me issues as well. It's probably not best I use it on a Mac, so I'm maybe considering to move to my PC. But with that said, thank you everyone for today's late lecture. I know I said it was going to be short, but we had a bit of heavy topic at the end, our most complicated join table. Let me add that bit of recording to the end of today's lecture, and I'll have that up as soon as possible. Okay, everyone? So thank you very much. I'm going to end the recording here. Okay. Well, actually, I do need to share my screen for one more second before we continue, and then we'll close this out. All right. So let's look at our schedule. Here we are. We have just finished the join tables lecture for today. Tomorrow, we're going to put it all together. We're going to connect Flask plus MySQL, and make full stack CRUD apps. Okay. Then we're going to continue that introduction of making a full stack CRUD app with relationships. And then on Monday and Tuesday, we're going to talk about validations. Okay, this has to do with entering in data into our app that we want to filter out. Okay, so validations is like a filter. All right, so tomorrow we're putting it all together. We're connecting our database to our server that holds, well, it's being held by Flask, and our data is being saved into session. That data we're going to be able to save to our database now through our CRUD statements. And we are now able to grab complicated data from our table. Now, for those joined tables that you saw there that were complicated at the end, that's not going to be necessary in order to pass the exam to have a super complex join statement like that. But I am going to work on finishing that lecture because I'm going to be miserable if I don't finish that thought there. Okay, so bear with us today. I know we had that little bit at the end that was a bit of a mystery, but I'm going to finish that and have that uploaded today. Okay, everyone? So thank you again for your participation. I look forward to seeing you guys tomorrow morning. Again, the end of day assignment is here. We have to download this file in order to get this view of this ERD, and then we run these queries. Okay, these queries can be submitted in a text file because they're queries. Okay, so they can look like here, this text file here. So there's some queries there. You can just make it a text. It's not super complex, right? So get some queries to work for you on your MySQL app, and then upload them when they're tested. And that's your assignment for the day. Once you finish that, we are on to full stack CRUD apps tomorrow. Okay, everyone, that is enough of me today. Let's go ahead and get back to work.